Hello, my name is Jose de Jesus Pesina, and today I'll be speaking about the perpendicular bisector theorem converse. So this is the statement of the theorem. A point is on the perpendicular bisector of a line segment if and only if it is equidistant from the endpoints of the line segment. So this is a non-rigorous demonstration. Consider line segment AB, which contains the midpoint of AB. In this case, we're calling it point C. And it is the midpoint, as you can see, because CA and CB are congruent. Line G is the perpendicular bisector of AB. And then point D is on the perpendicular bisector of AB. As we know, the perpendicular bisector passes through the midpoint, which is point C, and point D is on this perpendicular bisector. Notice that you can move this point around. Now, segments H and I show the distance between point D and the endpoints. So notice, regardless of the position of D, since D is a point on the perpendicular bisector, point D is always equidistant from the endpoints A and B. This is also regardless of the position of A. Notice that the distance remains equal, or the position of B. Notice the distance still remains equal. So back to the original position. Here. Now point E is on the same plane, and the segments J and K show the distance between point E and the endpoints. But notice the distance between point E and the endpoints is not equal. It is 33 units away from A and 37 units away from B. And notice the only time that this distance is equal is if point E is on the perpendicular bisector, just like point D. As soon as we move point D away from the perpendicular bisector, the distances are no longer equal. And this works all around. Notice the distances are different, and then the distances become the same distance from the endpoints. And this serves to show that in order for a point to be on the perpendicular bisector of a line segment, it must be equidistant from the endpoints of the line segment. It must be the same distance from each of the endpoints. Thank you for watching.